Hey guys, so we are finally finished with the kinematics portion. So the motion in 1D and motion in a plane, they cover the full syllabus of the kinematics motion. Right, so and of course now to the fun part, we'll go ahead towards solving some questions which have appeared in previous year's examination. So let's go ahead. So the questions which we'll be going through are actually the ones which have appeared in some previous year's papers. So it will actually give you a flair of what kind of questions actually come up in the examination, and that we have studied each and everything to solve them properly. Right, so let's go for the first question. So R vector is given in this form: cos omega t x cap plus sin omega t y cap, where omega is your constant. And we need to find out what exactly is the correct option. Right. So let's see now. And of course, you can remember one concept of simple differentiation, that when you want to go from R vector to V vector to A vector, what you need to do is differentiation, right? So we'll apply differentiation obviously here. And another concept that I want you to know is that when we want to check out like how two vectors are perpendicular, just remember the concept of dot product. Now dot product A dot B is actually AB cos theta, and if A dot B is equal to 0, given that A and B magnitude is non-zero, then that can only mean that cos theta is equal to 0, and that means theta is equal to 90 degree. Right, so a good way of checking whether two vectors are perpendicular is to check if their dot product is 0 or not. Right, and so and the other thing, that if they are parallel to R vector, if you can represent this in the similar manner. Right, so let's go and find out the velocity and acceleration vector. Now in this case, for differentiating d by dt of cos omega t, we are actually going to apply something which is known as chain rule. So now just remember that if this cos and sine, they are functions in itself, right? Trigonometric functions. So if their argument or the angle, so the angle is often called the argument. So if the argument is actually different to the variable with which respect to you are differentiating, then there will be something called chain rule. Then what you'll need to do is you simply first do the differentiation of this function. So differentiation of cos is nothing but minus sine. So you simply do minus sine and of course the angle as it is, and then you do this angle also with respect to this. So you also get the d theta by dt. So just remember, when things are in addition, then you differentiate them separately, like take one term each by each and then differentiate them. But when things are in multiplication, you also do differentiation chain wise. So first term and multiplied by second term and multiplied by third term if it were further there. Right, so this is how we do it, and this is why it is called chain rule. So now here your theta is nothing but omega t. So what we will get is minus sine omega t, and then if you differentiate d by dt of omega t, since omega is a constant, so you'll get is omega from here. Right, so this term will give you this, and this term will give you this. So now you got the v vector. Simply do the dot product. So I cap dot I cap is 1, I cap dot j cap is 0. Right, just remember what we studied in dot product, and you'll see that the dot product is actually 0. So that means that it is a sure confirmation that yes, these two vectors, they are perpendicular to each other. Let's find out the acceleration vector. It is nothing but d2r by dt square, or simply dv by dt. So simply differentiate this function again with respect to t, right? So omega you can actually take out because it is a constant, and again you apply the chain rule for differentiating these two as well. So one more omega will come from this and from this, right? So omega into omega, it will become omega square, and we have taken out omega square constant. Simply sine will become cos, right? And cos will become sine, and we have also taken out the minus sign common as well. And one astonishing thing you will notice is that this term, this whole term, is actually nothing but the r vector. Right, so what we are now finding out, that you can actually say acceleration vector is equal to minus omega square r vector. So this is a figure to represent the situation. If this is your origin from where you are measuring your position, and if this is your current position, then this is your position vector. This is your velocity vector, that is perpendicular, and acceleration, it is actually opposite to the r vector, right? So this way. So that means that this is correct, that v vector is perpendicular to r vector and a vector is directed away from origin. So your correct answer is 4. Right, so I hope this was clear and it was a good question, good application of concepts. Let's go for the next question. So if magnitude of sum of two vectors is equal to the magnitude of difference of these two vectors, then the angle between these two vectors is. Right. So read the question carefully and then simply state like what information you have. So if you simply take two general vectors as this, remember we are talking about only in like plane in motion in two plane, right? So that's why we are only taking two components, but you can do it with three components as well, and you will see that the answer is same actually. So if your A vector is this, B vector is this, so this is what we are given, right? So A vector plus B vector and its magnitude is actually equal to A vector minus B vector and its magnitude, right? So you simply add these two vectors. So adding is AX plus BX I cap, AY plus BY J cap, right? And its magnitude will be the under root of sum of the squares of the I component and X J component. So this is what you'll get for this, and this will give you this. Right, so simply it is a simple equation, you just solve it and this is what you will get, right? And I think it is should be clear, pretty clear by now, like what I'm trying to hint at, because we just did it in the previous question. This just simply cancel out 4, so this is what ax bx plus ay by is nothing but the dot product of these two vectors. And if your dot product is 0, then the angle is, of course, right, 90 degree. Right, so this is your correct answer. Right, pretty easy question. So next question. A stone falls under gravity freely. It covers h1, h2 and h3 distance in first 5 seconds, next 5 seconds and next 5 seconds respectively. What is the relation between h1, h2 and h3? So we need to find out what exactly is the relation. So always draw a figure because it will help you visualize it and make things much more easier, right? So just like if this is your point from where the stone is falling freely under gravity, right? Just assume that, see, there is nothing given like if the particle is following a projectile motion or not. If it was, then it would have been mentioned specifically that the person threw the stone at an angle this and this. Since it is not, so simply assume vertical motion, right? So if your particle is falling from this, so this is your t equal to 0, then this is t equal to 5, so this height is h1, and from t equal to 5 to t equal to 10, so this is your h2, and from t equal to 10 to t equal to 15, this is your h3. Right. Now common sense should dictate that as the stone is falling, the velocity will increase. Of course, this h1 will be less than this h2, and this h2 will be less than this h3. Right. So of course this option is eliminated, and yeah, this option is also eliminated, right? If we were lucky, like we could have simply eliminated another option and you could have actually gotten the correct answer. But now at least we know that yes, these two, one of these two answers is actually the correct answer, right? So always go for like eliminating options in case you are having a problem in solving the question. So now for A to B, simply we apply the kinematics equation, right? So what we get is V naught is equal to 0 here, and A is equal to G, right? So T is equal to 5 seconds for this. So simply apply the second kinematics equation. This is what you'll get. So H1 you got, right? No need to actually find out the actual value because we are not asked the actual value. So don't just be smart, right? Do smart work. Since you are not asked the actual value, no need to find out the actual value in itself, right? So just let it be like this. Let's do for A to C. So you have the V naught is equal to 0, this T is equal to 10 seconds, apply the second kinematics equation. So this HAC, so this entire height is this. Now if you simply want to find out H2, then what you need to do is this minus this height, so you will get H2, right? So 75g by 2 minus 25g by 2, you will actually get the this height BC, right? And for AD, if you want to find out, right, so what you will get is again apply the second kinematics equation for this entire duration, and this HAD you will get 225g by 2, right? And since this is yeah, so this HAC, I beg your pardon, this HAC was 100g by 2, and so 100 minus 25, this H2 was 275g by 2, right? Sorry, I spoke it wrongly earlier. And now when you got HAD, so simply if you subtract H, how much? Yeah, so HAC from HAD, So what you'll get is H3. So H3 is nothing but 125 G by 2. Right, and that's why I said no need to find out the exact value, because we don't need the exact values. So H3 you have this, H2 is this, and H1 is this. Of course, you can find out the relation that yes, this is the correct answer. Sorry, not we already eliminated this. Sorry, this is the correct answer. Right. So in next lesson, we'll see some more questions and then finally the summary. See ya.